Morning. So more teleprinter goodness, and maybe we might even get some progress today. We'll see. Well, I'm sure we'll get some progress, but we might get it to some activity. Maybe that's what I'm looking for. So I have got the ESP8266 that I was working on last time, which has software in it to try to send signals to the receiver unit, so we might be able to get it to type some stuff. There's a new ribbon for it floating around somewhere, so we might get that fitted as well if we get as far as making it actually do things. And Paul has got this little array of goodies. So what are we doing with these, Paul?
So the idea is to get them to power the electromagnet, and that's the electromagnet that sets the pins as the data comes in to correspond to each letter. So yeah, that's the plan for that.
So this is going to be the kind of electronics that interface with the microcontroller,
yeah,
to drive the electromagnet to make it do things. But that's only going to happen if this motor is spinning around at the right kind of speed. And that brings us to Mike.
G'day. Well, we put the power supply together last time, and the output voltage was a bit higher than we expected. So it's running around about 120 volts with load. So we found a nice little voltage regulator, a TL783 I think it is, which is a 125 volt regulator. So with a cheap Velleman PC to get us up and running quickly, we can regulate it down to say 110 volts, so that it's within the range of the motor.
Excellent. So that's today's, let me just bring this back here. Yes, get all of us in. So that's today's plan, and we will see how we get on. Speak to you soon. Right, we've got the ribbon has been rewound onto the old spools, so that it can then be refitted, which means we can get these really super awesome danger switch off power at wall socket and remove plug before changing ink ribbon. I'm not quite sure why it's so dangerous to change the ink ribbon on teleprinters, but maybe it's because they might kind of suddenly burst to life and sort of hit you lots. I don't know. So that's where we are. The ribbon's in. We've had a slight change of tack with the circuitry stuff. So instead of the nice, actually I might as well talk to the camera rather than point it randomly at the desk. So Paul has been looking at the circuit, and with his nice transistors that we were looking at earlier, and we decided that
just for expedience, it's all compacted. We just use a integrated chip, H-bridge.
So this is because we're wanting to ideally have the circuitry cope with plus and minus 80 volts. That just complicates things a bit. So, like, you've done some looking into that.
Yeah.
I know. So there'll be some more work on that, but in the short term, for getting the printer up and running and just see if we can like sample some stuff, then we figured we would use a good old L293D H-bridge, which means that we have had to swap to an Arduino because the H-bridge is 5 volt logic and the ESP will only be 3.3 volt logic. So we've gone, but you know, the code will work identically on either of them. So we've uploaded the code to an Uno, and then we're using the H-bridge and basically treating the electromagnet like it's a bidirectional motor. So rather than have plus and minus 15 volts, we've just got plus 15 volts, and we're just going to reverse the polarity in order to kind of switch between plus and minus. And so the next step, so we got that wired in, so you know, 15 volts on the bench power supply, which is going to power the Arduino and provide the 15 volts to go into the electromagnet. And when it first boots up the code will send out a hello world, and then after that it will do accepting serial input. Now obviously that would need the USB cable to be plugged in, but just from a kind of being an abundance of caution, we haven't got my laptop plugged into it at the moment when we first turn it on. And we're also not going to run the motor when we first turn it on either. So this, the output from the H bridge is then round into this terminal block, which lets, and this is the kind of data cable into the teleprinter. So we've got it wired into the two wires that will do the either side of the electromagnet. And so the idea is that when we turn it on, it should flick this back and forth, and because we're not running the motor, it's not going to print anything, but we should just see this flick back and forth at 50 baud and send hello world. So that's our next step. So maybe if I kind of get where we can see the electromagnet arm, and if you want to maybe do the honours, Paul, and turn it on.
I hope that's connected correct.
And we'll see what happens. So that, I mean, all of you have been watching and checking the board, the Bordeaux code and stuff. You'll have, decoded that, and you'll see that it's all working perfectly. Or like me, you'll just be going, well, it flicked from side to side, so that's probably a good sign. I mean, should we try, should we plug a USB cable into it and try sending some signals to watch it go from side to side?
Turn the motor on and see whether it moves the head.
Let's go for sending some signals to it first, and then power the motor up, because then we can talk to Mike's been doing stuff on the motor side of things whilst Paul and I have been working on the electronics. So we'll try this, and then we'll have a chat to Mike about what he's been up to. So is that going to reach that USB cable?
I'll need to take out.
No, you won't. You can just power. It'll all be fine.
Okay.
And if it won't be fine, then it's on camera of me saying you'll be fine when I'm going, Paul, you've killed my laptop.
Okay.
So there we go. And the tricky bit now is that I need a third hand, because I'm holding. Oh, actually, it is just a third. The power supply's on, isn't it? Oh, you turned it off. Ah, okay.
That one?
I have no idea whether this is going to be visible at all. What are we going to send message wise? So we're just going to I don't know, let's say ciao and question mark, because that's more interesting. So set that message. If I hit the send button, hopefully we'll be able to hear it going click. And we can't. Why is it not? Possibly because the Arduino might not be happy. Maybe it's switched serial ports on us. Let's go and see. Yes, it has switched serial ports on us. And then open this, and that's probably going to reset the Arduino, is it? Yeah. So that was the, you can see it printing out what it's sending, and you can hear it clicking. And so if we then just do ciao, return. So that's sent ciao. So that seems to be doing the right sort of thing. So we'll work out what we're doing with the power supply and get back to you in a minute. Well, we powered it on without the camera running, because I'm an idiot and I should have started the camera. And it seemed to do some stuff, but it also seemed to hold the electromagnet in space, and so it just ran continually, whereas it should be held in mark and so not run continually. So we're going to do that again, where if we turn on the
communications or the motor?
let's do, I don't know, do we want comms or motor first?
Motor first.
Okay, we can do motor first.
I'd say.
So the motor power supply is turned on, but the power to the motor isn't turned on. So if I flick this switch, that's going to sit. Right, so that's how it should normally sit. So that's me manually doing it because there's no comms. And if we turn the power supply to the comms unit on, then we should get it springing to life. And then it stopped. I mean, that's, yeah, who knows what it tried to print, but it did seem to try to print things.
And that was seemed to like the regular characters.
So that's nice. So if I plug in the plug in the USB connection and find my mouse and start the serial monitor. So this will reboot the Arduino when I open the serial monitor. So that will mean that it will go through the signal of sending marks and spaces. Send hello world again. Open that. It should. Maybe it won't. Okay. Because it's powered separately. Okay, so it won't reboot the Arduino at all. I was lying. So, do we want to send a single character? We send an A, and not very much happens. Oh, it's not. Is this? Is that definitely plugged in?
Yep.
That's still an ATM1. That'll be why. And it's gone back to ATM0 because I've unplugged the USB and plugged it back in again. So maybe this will reset the Arduino now that I'm actually going to open the serial port it's connected to. Yes, there we go. So that has sent some stuff. There should have been a punctuation at the very end, a question mark, but if I send an A, this is going to send two codes, because it'll send the letters code and then the A code. So they were the two codes it should have sent. So I mean, it sends you another A. Okay. Yeah, the other thing, maybe we should not send a new line and carriage return at the end. So you were getting an A and then a carriage return, because the carriage return and a new line, probably. Right. So you were getting, 4 codes the first time and then 3 codes the times after that. So in the Arduino serial monitor, I can send no line ending. So if I send an A, this should just send a single character. And then I can send a B and a C. So yeah, I guess the next thing we might want to see which character it's printing, or put the carriage on and see if it's going to actually print something out. Yeah, okay. So we have the paper carriage back onto the printer. It's actually really simple there's like a little latch and it swivels round and lifts off, and so you kind of put it onto the pivot at that side, and then there we go. Like,
lift it out and put it back in again.
So it is. Yep. And now we can power it up. And then we want to be really ambitious and type hello. send to it. Had you powered the...
I just switched it to amps.
Oh, okay. Yeah, I'm sorry. Just checking that the Arduino should still be running and still connected on the serial thing. So we are just going to send the word hello when I hit send on this. But the screen isn't an interesting thing to be looking at when that happens. In an overly optimistic, it's all going to be fine. I'll stick the camera there. So it didn't seem to actually go side to side at all. But it typed something. All on the same. So yeah, the next thing to do would be to send A. Seems to send two things, and it has not. Is that an A? That looks more like an M to me. But
Got two characters, but yeah, it looks like an M.
okay. I did just.
That was time off.
No, because if it was a timeout, then it would have turned the motor off. Because that's what the. Yeah. Well, time to investigate a bit further and work out what it's doing, but it's put ink onto paper, but maybe not the ink we wanted. We'll investigate further. Right, so we have a new recruit as well. Tom has joined us.
Hello.
And Paul was doing some good looking at when we were trying to type an A and we were getting an M. He spotted, well, he was looking at the bit patterns, so I'll let him, and he's got a diagram, so I'm going to let him talk you through both the what he found and the diagram.
So the idea is when we send an A, the bit pattern should come out as expected 11000. If it's received in that same bit pattern, we just say it's gone through without any conversion. There are, I suppose, like two ways we could transform that. We could invert all the bits into 00111 and it would come out as an M. Or we could flip the bits left to right and it would come out as an O. Or we could do both, invert and flip them out and come out as a 11100, as a U. So we send an A and we see what we get.
Yeah, and I guess given that we think we got an M last time, it's looking like this is, I don't know, yeah, plausible explanation for what's gone wrong, and then we need to work out why we're getting marks when we're sending spaces, or yeah, whether it's a bug in my code or in the wiring or whatever. But yeah, we're going to send each of these in alphabetical order. We've put some fresh modern paper so that we don't just waste all of that nice Second World War paper with our experiments. And as Mike suggested, what we should do is, yeah, we'll send each of those 4 characters one at a time, and in between we'll manually rotate the paper up because the left to right paper feed of the carriage isn't working at the moment, and we're not going to investigate that right now. So that should let us see what we're getting.
And also, if it looks like it's printing multiple characters on top of each other, I'm going to try and manually feed it quickly to see if I can actually catch the multiple characters.
Okay.
Because it might be the N characters, not that, so there's multiple characters.
Yep.
Let's try it and see if it works.
Yeah, yeah. So, if
power
we
it on.
power it on.
So when you're ready.
And so I'm going to send an A.
That's printed an M.
That's printed an M, okay. If I send an M,
You've got a T.
we got a T. Interesting. Ah, it's got some sort of special built-in code ciphering thing. You know, it's like an Enigma machine. No, what was the other? There was no.
Oh yeah.
O is next.
Got another T.
O is also a T. Interesting. And then a U.
You've got an O.
And we got an O.
But the code for those is only one bit different, isn't it? For M&O, it's only one bit different. So it's got 3 ones at the end there, and it's only got 2 ones at the end there. So they're quite similar.
Yeah. Good point. Yeah. So
let's do 2 or 3 more characters outside.
Should we do a T? Because we've got a T. We've got a lot of T's printed out. Let's see what happens if we try and print a T. Actually, I'm just wondering whether what I should do is grab a pen and give Mike a pen so that he can write. You'll need to twist the silver bit to get the nib out of it. Silver bit at the end, twist. There you go.
So the first one was
that was an A.
Then an M. Then an O.
And then U was the last one, wasn't it? We should send an R next, so we can write a more and see if we love the teleprinter. So I'm going to go with an R next, just to complete the word on the right hand side.
got 2 letters.
We've got 2 letters for that one. Interesting.
Like a K and a V.
Right, so that should have been an R. Should I send a Y as well, Paul, which is the inverse? No, we'll do a T in a bit, yeah. Like R and Y are good because they're mark, space, mark, space, mark, or space, mark, space, mark, space. So they're the inverse of each other. But yeah, we should... Have I sent a Y? No, I haven't sent a Y. I'm going to do a Y next.
That's printed 2 characters again.
Okay, I wonder if there's a speed thing then, if that is... Like, because there's a lot of transitions in an R and a Y. So maybe it's getting 2 characters because it's running at the wrong baud rate between send and receive. And then we were going to send a T.
Oh no.
We got no. Interesting. Right. Well, rather than just leave you watching us scratching our heads for a bit, we're going to scratch our heads for a bit off camera. And then maybe we'll come back with some knowledge or another test to do. Well, given that we sometimes got 2 characters, particularly when we were sending R and Y, which have lots of transitions in them, we are wondering whether the baud rate's running whether the motor's running at the right speed, which is something we wondered about anyway, because the power supply, if you remember from the last video, the power supply is running at 120-ish volts, and the motor really wants 110 volts. So Paul has broken out his awesome LED timing circuit, which, if you've been watching all along, you'll remember from one of the earlier episodes. So what's this doing, Paul?
This is flashing at 50 flashes per second.
So yeah, you can't really see it, I suppose, especially because this camera, I think, is set up so that it doesn't pick up 50 hertz flicker, because the lights are 50 hertz flicker. So yeah, it probably isn't going to come through too well on the camera, but it is flashing at 50 hertz coming from this signal generator.
Could you drop the frequency so the camera will pick it up, just for demonstration?
So Paul's just going to drop the frequency down, and now you can see it's much more flashy. I hope. I mean, I can see on the little viewfinder camera, so yeah, we'll hope it's doing that. And the reason we're doing this, Paul,
is to catch this thing spinning, and if it should be spinning at the right speed, we should expect to see it land, expect to see it flash right as each white square goes by. So they should look static.
So that's a kind of a calibration drum on the motor,
Stroboscopic,
to let the strobe pick it up and do stuff. So if we power it on, then we can see how static it is. but if I remember rightly from last time, there was a lot of peering very closely at it in order to just about pick up a kind of minor variation on the edge. And I don't think it films especially well, but you can use maybe get a bit less light coming in.
There you go. You see it?
Just about.
It's right there.
Yeah.
I can try and
So it is slowly moving back.
Yeah, okay. So at 40, you can obviously run. At 60,
Wow, that's a bit clearer, isn't
at
it?
60,
It's still drifting a little bit, isn't it?
I can go down to single figures. Now about 50, 51, 52, 53, going back down, 52, 51, 50, 49,
Okay.
50.
So it is running at the right speed then?
Yeah, I can go even, I can go even finer. I'm going to go up from 50, 50.1. At 50.1 you can see that stroke going up. At 50, 49.9,
Going down.
50.
So we think it's running at the right speed then? Yeah. Okay. So the motor seems to be running at the right speed. So it's probably not that that's causing our characters to be wrong. So now we need to do some more pondering. Paul has broken out his oscilloscope because we figured it would be good to see, just check what's coming out on the electronic side of things and check the H-bridge, how quickly that's switching, things like that. So he has the scope ready and poised to capture on the signal coming out of the H-bridge, and we are going to send, which character are we going to send, Paul?
We could send a letter R.
So we want to send a letter R, and get that in a bit.
But we're leaving the motor off just so we can see what the response is
Yeah,
from the signal by itself.
Yes, good call, Tom. Yeah, and also it means that you can hear us
Yeah.
a little bit more on the video because we don't have a noisy teleprinter driving. Well, I mean, it'll be clicking because the electromagnet is still powered up, so it will click across. But if we send an R now, let's see what we get.
Oscilloscope is too fast. That's the start bit.
Right. We didn't get very many flicking of the.
Is the fast one?
Yeah.
Yeah, I would have thought we'd have got more clicking of the electromagnet.
Try again.
So we'll send another R. It's possible.
The motor needs to be running.
Well, no, it's possible that the Arduino isn't, like, because we've been playing around with a bunch of stuff. This might send lots of things, but it's possible we've unplugged the Arduino at some point, and so the port. Oh no, port seems to be correct.
We should see the LEDs flashing on the Arduino.
So that should be sending lots of stuff. This is sending hello world.
Yes, I can see a lot of flashing.
Okay. I wonder why we're not getting
I can hear it. I can hear
any activity on the solenoid, on the electromagnet.
Should we try turning
Okay.
it on and
We can send an R from this now. So the signal coming out of this should be going to the Arduino.
So it's right time you mentioned it before, where it does actually activate the solenoid, or should do with the power supply.
I can hear it. I can hear it making a little.
You think it's just trying and
I
it's
think
not quite
it's
getting
trying,
enough?
but I don't think it's getting enough.
Right. It's possible we haven't got enough voltage on the power supply. We've nudged that or something.
Or is there something mechanical that needs to...
I think we need to switch it back on and try it again.
Yeah, I mean we can switch it back on and try it. It shouldn't make any difference
It's going
for
to
the
be a bit
signaling.
noisy though, isn't it?
Yeah.
Oh, it went clipping then. Okay, so try sending hello world again.
Well, I can just send an R
Yeah.
once, yeah.
Yeah.
So that was an R, and we have probably not as many. Is that as many bits as we would want?
Space, mark, space, mark.
Okay, so is that what we would expect? So what did you just read that out as, Paul?
Space, mark, space, mark.
Which is the same as is written in my serial monitor output. So that probably means that we're doing the right thing. And what did we get on the... Well, we've had a few characters. Let's send another one and see what the teleprinter is going to send. And that seems to do 2 characters. So that, yeah, that bottom one, if you want to mark it in, Tom, was an R.
Sure.
I think the one above was an R as well, but the bottom one definitely is an R. Curious. Well, we've been doing some, timing of the trace we get on the oscilloscope and some maths, and I was checking, and I think I might have found a bug in my code. I mean, I know you'll find it hard to believe, but basically the code here where it's delaying was doing 1000 divided by 50 times 2 is what it looked like, and that ends up being 40, I think, and it should be 10 because it should be 1000 divided by 50 times 2. So I'm now going to upload the code to the Arduino, and then it will spring to life once I send some stuff up to it. So that's, yeah, now it should be typing out hello world.
It's just not advancing the character.
But the carriage isn't advancing. And if we, Tom, if you want to just scroll up a little tiny bit so that we have clean paper.
Yeah.
And then we can try typing an R again. Are you ready to capture it, Paul?
Try that.
Yeah. Sending an R now.
Nothing came out.
Interesting. Oh well. So much for us kind of magically finding everything working. What, send another R?
Aye. Okay.
Again, nothing.
Should we try a Y just out of interest? So we've got a Y.
That's inverted nicely.
Okay, we didn't get anything out of the teleprinter, which is interesting. I'm going to go with an A.
Yeah.
And I don't know, an M.
I got a Y, that A got a Y.
Oh, interesting. I wonder if we're not getting enough stop bits then or
Just send
something.
another A, please, just to confirm that
So there's an A.
that came out as a B.
Okay, do you want another A?
Just a second. Another A, please. That's another B.
Let's do a bit more calculation and measure the duration.
So, yeah.
And then see how we get the closer to the duration.
We'll do a bit more debugging, and then and I can stick the camera on charge as well when we're doing that. So yeah, back to some more head scratching. Well, while Paul's just getting all set up, we've decided, given that we're getting a slightly odd timing thing, what would be a useful test would be to actually run loopback, so that we can use the keyboard and then loop it back to the receiver to then see what see what we print, because if that, that will all be in sync with itself because it's running at the same speed off the same motor. So if there's any difference in baud rate between my laptop or between the Arduino and the motor, that would be causing strange characters. But the keyboard and the receiver, both driven by the same motor, will be running in sync. And so if that prints what we expect, then it's a difference in baud rate problem. If it doesn't, then that's something else we're going to have to dig into further. So we've taken the bench power supply, tied running both sides of it at 15 volts to tie them together, so we're back to having plus and minus 15 volts. We've got the loop back wire, so the two power ones are coming in here, which feeds into the system. We've got the loop back, which takes the signal from the transmitter, feeds it back in, so it'll go to the receiver. Yeah, I think that's, and we're going to use the scope to see what's coming out, just so that we can keep an eye and confirm what we think about whether it's marks and spaces and which are high voltage and which are low voltage, etc, etc. And so I think the next step is going to be
power on the
data side. So that's up.
You should see a voltage on there, I think.
It might not trigger because it hasn't transitioned. It might not have transitioned past the trigger point.
Okay.
So we can power on, and then
half an hour. Do you remember where the keyboard is?
that hasn't sent anything. Interesting. So that's running around just fine in the signal. But we're not getting anything coming out of the receiver. Yeah, did the scope catch anything when we were sending?
Nope. I just checked the highs and the lows.
So that did trigger.
That was just me.
Yeah. Yeah, we did get a click from the teleprinters. Curiouser and curiouser.
Let's check our wiring.
Yeah, maybe run through the wiring and then we'll get back to you. We've been diagnosing some stuff with the loop back. The keyboard doesn't seem to be sending anything. It's sending marks, it's sending the send and receive correctly, but the scope isn't picking up any signal from the keyboard like transmitter unit. So that's why the keys didn't seem to be sending anything to the receiver. So the receiver's working fine because it's just not getting a signal. And then we've been, if I just stick that down into there, you can see this is the sort of contacts as it kind of, when you press a key, these levers go back and forth, which changes some of these toggles, and as you crank it round, these will drop or not, which basically makes this little thing go from side to side, so that you can switch the mark, is it that? No, space is that side, so that's the space voltage.
15 volts.
15 volts.
And that is the mark voltage, and it's live, as I've just been reminded. It's only 15 volts. And then this is the output. And so Paul is going to monitor the output, and Mike is going to manually crank
So press the key.
through.
We're on letter G.
And so you can see the levers going up and down, and we are getting absolutely nothing out of the oscilloscope.
So again, I'll do an R.
Yeah, interesting.
That's it.
So yeah, that's where. Well. Yeah, that's where we're up to at the moment. And we're still puzzled. Much puzzling, but we have got ink on paper. So there's been some progress.
But the wrong ink.
Admittedly the wrong ink, yeah. It's all the right ink, just in the wrong order. Isn't that the correct phrase? Yeah. So I'm not sure how much more we're going to... Well, yeah, we'll probably poke at it a bit more.
Some
Before we-
our audience will recognise more common wise cribs.
Well, you think our audience is old enough for that? Yeah, they probably are.
We're going to get some candlesticks out of it later.
4 of them. Some signal on the oscilloscope from the transmitter, the keyboard unit. So we've done a bit of just poking in the transmitter section and cleaned up the contacts a bit, mostly. So now the moment of truth is going to be if we can... oh, that sounded like it did something. So what key are you pressing there, Mike?
That's an R.
That's an R.
Not typing though.
Oh, we haven't got the loop back in at the moment, have we?
Yes, we have.
Have we?
Yeah.
So why isn't it receiving yet then?
Nice.
So the scope is receiving the key presses. But the receiver isn't receiving the key presses. It's a little odd. So some progress, but still not quite enough progress. The investigations continue. Right. We're going to call it a day. I think it's defeated us now. We think there's we need to work out the adjustments for the transmitter and get that to transmit reliably, to then receive stuff on the other end, and then hopefully the loop back will work then. So still. And then the other thing we need to remember, or need to not remember, but it surprises everybody, is that the machine turns itself off after a certain amount of time, because it lifts up this little weight and has an auto power off, and that's caught me and Mike out, as you've just seen it catch Mike out, because if you manage to hit one of the keys to make it do something, the weight drops down and switches the motor back on, and it all starts to run, and you just go, oh yeah, it's actually turned on, isn't it? So yeah, but we did, I think we should finish on, if I can get the camera close enough, which I probably can't, but you can see there's actual, it's got ink onto paper, and as you can see from the stuff on the right, it's not the ink that we wanted, but it seems to be quite a good step forwards. And on that note, we shall bid you adieu.